Hello, Math 2. This is Mrs. Bricky, and this video is for Unit 8, Lesson 5. This will be Part A, where we are looking at modeling with quadratic functions. So quadratic functions are often used when we're modeling things that are being thrown or dropped or jumping, and that's because we have gravity on our planet, and gravity is an acceleration that pulls us down. And so when things are in flight or jumping or being thrown or being dropped, their motion follows a quadratic pattern. Now, sometimes the quadratic, like with the dropping, it might not be spread out forward, but like the speed with which it would drop down still follows a quadratic pattern. So you can, in some ways, you can think about these x-axes as like spreading time out. So we're modeling the height of the ball as time passes. So if you were in class, we did a sort thinking about for different problems what we might be looking for. Are we looking for the vertex? Are we looking for the zero? So if your problem asks you how long until it hits the height, until it reaches the max height, then you're looking for the x value of the vertex. And in most cases, we would use the axis of symmetry to find that. If it asks you for the maximum height, you're just looking for the y value of the vertex. If it asks you for how long until it hits the ground, or if it asks you, and the ground, by the way, would be y equals 0 is the ground, or the height is 0. Or it might ask you how long is it in the air. If you get those sorts of questions, you're looking for an x value, and you're looking for the positive x value, which we might get from the quadratic form or from factoring or from using the square root method. So we're going to go through just a couple of examples here. So example 1, Bill hikes to the top of a large cliff that's 121 meters high, and he accidentally drops his backpack off the edge. The height of the backpack in meters after t seconds can be modeled by the equation h of t equals negative 5t squared plus 121. How long will it take the backpack to reach a height of 50 meters? So we want the height in the equation to be 50 meters, and height goes right here. So we're going to set h equal to 50 and solve for time. So 50 equals negative 5t squared plus 121. We can use a square root method to solve this. So I'm going to go ahead and try to isolate that t squared. And again, the reason I can use that square root method is because I don't have a t term. I just have a t squared in my equation. So we're going to get it by itself. So I'm going to subtract 121 to get negative 71 equals negative 5t squared. Then we're going to divide both sides of our equation by negative 5. So that gives me t squared is equal to negative 71 divided by negative 5. If I do that in my calculator, I get 14.2. Got a little extra decimal point there. And so then I can take the square root. Now, normally when we root both sides of the equation, we get this plus or minus symbol showing up, but we are looking for the positive root here. So we're going to take the positive answer. That's going to be 3.77 seconds. So it falls for 3.77 seconds, and at that time, it's at a height of 50 feet above the ground. Sorry, 50 meters above the ground. All right, so then our next question here is, how long until the backpack reaches the ground? Well, the ground is height 0. So we're going to set the height equal to 0 and solve for t. So 0 equals negative 5t squared plus 121. So we can, again, subtract. We're going to try to isolate t squared. So I have negative 121 equals negative 5t squared. We're going to divide both sides of our equation by negative 5. Negative 121 divided by negative 5 is 24.2. And when we square root both sides of our equation, we do have a positive and negative answer, but for our word problem here, we're going to take the positive answer as our solution because negative is weird. So we get 4.92 seconds. So that means like you could think of like the backpack as, falling off this cliff. The cliff is 121 meters high. Little backpack falls. And it hits that 50-meter mark, 50 meters high after 3.77 seconds, and it splats on the ground, which is a height of 0 at 4.92 seconds. Okay, the next example, we've got the height in inches of a frog's jump is modeled by the quadratic equation h of t equals 60t minus 75t squared, where the time t, which is the time after it jumped, is measured in seconds. So find h of 0 and find h of 0.8. So h of 0 would be 60 times 0 minus 75 times 0 squared, and that is 0. H of 0.8 is 60 times 0.8 minus 75 times 0.8 squared. And if you crunch that, it is also 0. So what do these values mean in terms of the frog's jump? Well, he started his jump at time 0. So if we were looking at it on a graph, if this is the time axis, he started his jump at time 0, and this means he landed at time 0.8. So this would be time 0.8. And those were in seconds. So our next question is, how much time after the frog jumped did the frog reach the maximum? Well, the maximum would be that we're looking for the value of the vertex. With the picture of the graph that I drew, you can maybe just see that that is going to happen at 0.4 seconds because it's going to be halfway between those two intercepts. But if you didn't notice the graph, or if you hadn't sketched the graph, you could, of course, use the axis of symmetry here. Our b value, the one in front of the regular t, is 60, so negative 60 divided by 2. And this is our a value, negative 75, because it's the coefficient of our squared term. So if you did it this way, you would also get 0.4 seconds. And here's a graph of the frog's jump. So you can see that we were correct. The highest point in the frog's jump occurred at 0.4 seconds. Okay, Last example, we've got an equation h equals 2 plus 23.7t minus 4.9t squared, and that represents the height of a pumpkin that is catapulted up in the air as a function of time in seconds. The height is measured in meters above the ground, and the pumpkin is shot at a vertical velocity of 23 meters per second. We want to know what is the maximum height that that pumpkin reaches. So the maximum height, we're looking for a y value at the vertex. A y value at the vertex. So if we're thinking about a quadratic, the vertex happens when x is equal to the axis of symmetry. So we're going to start by calculating our axis of symmetry. Now, this equation and really the last one are maybe a little bit tricky because they are not in standard form. If we put them into standard form, if we put those terms in the traditional order, it would be negative 4.9t squared plus 23.7t plus 2. So the a value is the 4.9, the b value is the 23.7, and the c value is 2. So negative b over 2a would be negative 23.7 over 2 times negative 4.9. If we calculate that, we get an axis of symmetry of 2.42 seconds. And that's the time that it takes to reach its max height. But our question is, what is the max height? So that means we need to sub 2.42 into our equation to find out the y value of that max height. So the height is going to be negative 4.9 times 2.42 squared plus 23.7 times 2.42 plus 2. And so if you calculate that in your calculator, that gives us a maximum height of 30.66 meters. So that is the height that the pumpkin reaches. All right, that's the end of this video. That's part 1, so there's another part. But you should maybe try the assignment before you watch the part B video, and let me or your teacher know if you have any questions. Thank you.